project entitles the development of a pass-through disk drive controller, which would allow multiple serial ATA, or abbreviated SATA, disk drives to be connected together in a daisy chain or waterfall fashion. Now, the end result of this project is to see all these disk drives, daisy-chained disk drives, appear and behave as one large drive. This would be an advantage for the user to be able to extend their storage in a more scalable and easy manner. On the hardware side, the challenge was to develop this pass-through device. And the functionality of this device is to grab a user request, whether the instruction be a read or write to the disk drive, determine if it is in the correct location in the chain. If so, go to the drive and process the request. Otherwise, send the request down to the next controller in the chain. This involves the development of a printed circuit board, which would allow both SATA interfacing capabilities and basic storage processing. The ARM processor, which we chose the microprocessor, which we chose for our printed circuit board, is an ARM processor, which allows for both SATA interfacing and data processing. In addition to having this on our printed circuit board, we also require a port multiplier to allow to make the daisy chain even possible. On the software side, we used Microsoft Visual Studio to develop a mock Windows Disk Utility interface. The purpose of this interface is to exercise these daisy chain drives. We've written routines in C++ to do basic storage management and to give this utility actual functionality. And these routines include reading and writing a raw sector of a disk drive, initializing a disk drive, and creating a simple partition on a disk drive. Excuse me. Okay, I'm sorry. This semester, during the course of this semester, Jorge and I worked on the hardware, while Angel and myself worked on the software. Next semester, we expect to have our printed circuit board developed and our ARM processor programmed, and finally begin exercising the daisy chain disk on our utility interface. Thank you for your time and attention. Are there any questions?
We have 2 minutes for questions.
Yes.
So this doesn't exist yet? It's just the design phases at this point?
Yes, we're this year in design 1, and we were tasked this project, and we don't believe it exists yet. It's actually patented by the gentleman who assigned it to us. His name is Dr. Kevin Kluber.
So are you modeling what latencies you're going to reduce by having this? I'm looking at it and passing on. There's got to be some latency associated with that.
We haven't considered that actually, but you guys might have input.
There absolutely will be latency considered in there, but right now what we're concerned with is getting the functionality with it. If you have like a live storage available to you, most people aren't really concerned with latency.
But if you're going to do one-to-many on the multiplier, or are you going to be passing in daisy chain style down the line?
So what the multiplier does is it allows you to pass through information. Because the processor we're using right now only has one SATA interface, but the port multiplier will allow us to interface over multiple drives. So what it will do is one of the ports will connect to a hard drive, and 2 remaining ports will connect to other devices like it, so we can pass through the information.
So if I'm on the left side and I want to get to the third hard drive, I have to pass through
And continue passing through different
each of the latency and the process that I look at to figure out where it's in.
So what other factors did you decided to use this microprocessor out of so many options in the market?
I'm sorry?
And what is the reason you selected that microprocessor AM1808?
Well, because it's a single solution. If we didn't choose that certain microprocessor, we would need a separate interface chip, a SATA interface chip, and a processor.